Welcome to the Fields and Keys Participation Project. In this assignment, we will go through the education database to determine the best choices for data types for each of the fields, for primary and composite keys for each table, and to determine the relationships that we wish to create between each table. To start, I've downloaded and extracted the data files for this project. I've opened up here the education database in Access. Let's begin with step 3. We're going to go through each table within our database, and we're going to look at each field to determine what data type we should use for that field. Depending on the data that's going to be stored in that field, we might want to choose a different data type. If we're dealing with numeric values, we'll want to use a number type. If we're dealing with letters, we'll want a short text or long text type, for example. We're going to work through these tables one by one here. Starting off with analysis questions, I'll right-click and go to Design View. By default, we have each of the fields in the database set up as a short text option. Now, short text can store alphanumeric characters, so those would be letters, numbers, special things like punctuation marks, up to 255 characters long. Let's go and take a look at the data that we have in the analysis questions table, which right now actually isn't anything. But we're going to have the question number, which will be the step that we're answering. So it might be something like 7A. So that's, since it has both a letter and a number, we want a short text field because that can store alphanumeric values, but there's only going to be a couple characters there. So short text works well for that. Now for our response, we might have multiple sentences. 255 characters might not be enough to accommodate what we're going to write, so we'll want to use the long text option. Let's go back over to Design View and set things up. Question number, short text is fine there. Response, though, we said that we wanted to use the long text option, so I'm going to select that from the menu. So by using long text, we're able to use long responses of up to about 65,000 characters. That's going to give us way more space than we'll ever need, but it's good to be prepared. Once we've changed the data type for the response field, let's save our changes and close out of the table. Continuing on, let's double-click and open up the annual statistics table. We'll go through each of the fields within this table, starting with the school statistics ID field. As we'll find out later in the project, this is going to be our primary key for this table. We have an integer value that uniquely represents each of the records. So we'll want to use a number type that's capable of storing integers. The next field, the county field, we have short string of text here. Short text is going to be plenty long to be able to store this field, so we'll set it to that. The same goes for school name. While it's a little bit longer text, it's still well under 255 characters, so short text is going to be our best option here. School years is a little bit more complicated. As you can see, we have two numbers for the years that are joined by a dash. Since the dash is not actually a number, we can't use a number type. We're going to have to use one of the text options, and since it's a short text string, short text is going to be our best bet. The enrollment here is an integer number. These are all whole numbers, so we'll want to use an integer type number. For the attendance rate and graduation rate, you can see that we have decimal numbers that are all between 0 and 1. That's because these are all actually percentages, which are stored in the database as decimal numbers between 0 and 1. We'll want to use the number type for this, but we're going to have to adjust the field size to make sure that it's capable of storing the decimal portion, the part after the point. If we just use an integer, it's going to drop all that, and an integer value would only be able to represent 0% or 100%. So we need to make sure that we're capable of storing a number that has that decimal part. West Test student count has a whole number, so we'll want to use integers for this. West Test math proficiency, reading proficiency, science proficiency, and social studies proficiency, like the attendance rate, graduation rate, these are all percentages. So we'll want to use a number type field that's capable of storing a decimal component. Let's go over to Design View now. In Design View, we want to make sure that we set each of the data types that we discussed when we looked at things in Datasheet View. For School Statistics ID, If this was a brand new field, we would probably want to use the auto number type. With auto number, Access is going to make sure that each record has a brand new unique value, which is great for a primary key. But since there are already values within this field, it's not going to allow us to use that type. The next best option is going to be the number data type. Down here at the bottom, we can see that Access has defaulted to being a long integer, which is capable of storing numbers up to about 2 million. So that's going to give us plenty of room. There are some shorter options. Byte can store numbers up to 255 and integer up to about 32,000. While there's a little bit of disk space savings with those numbers, it's really not worth the risk that you might sometimes run out of space in the future with your actual numbers that you can store. It's easier just to stick with the default, so we'll use long integer. For county name, the short text type is a good fit there, so we'll stick with that. Same goes for school name and school year. For enrollment, we said that those were whole numbers, and so I'm going to change that to a number type. And realistically, we could go and use the integer size since it's unlikely that we're going to have more than 32,000 students in the school, but there's not a good reason to change, really. Disk space is pretty cheap at this point in time, so we'll just stick with long integer there. Attendance rate, that's going to be a percentage, we said, so we will need to change that to the number type, and we must change the field size. If we don't change the field size, the percentage is not going to work correctly. For this case here, we want to use double as the option. Don't get confused by the one called decimal. It's really a very special case that you want to use decimal. You're never going to see it in CS 101 that you would want to use decimal. Double is what you're going to want to use. It refers to double precision as a particular type of decimal number. Double is the option that you want to use if you're going to have a decimal part to a number. Now, since these are percentages, we can actually go under the format row here and choose to format them as percentages. So they'll get displayed looking like percentages. And if we want, we can set number of decimal places. So right now we'll just keep it at auto, but if we wanted to say that we always had 2 decimal places, we could go and choose that option. Let's go and do the graduation rate, and this one's also percentage. So I'm going to choose the number type, change the field size to double, and format it as a %. The West Test student count we said was going to be a whole number, an integer. So I'll choose number and we'll leave that as long integer. West Test math proficiency is going to be another percentage. So we'll choose number, double field size, and format it as a %. And we'll do the same for the remaining fields. Those are all percentages as well. Now that I've made these changes, I'm going to save my table. You will get a message here that says some data might be lost. This is because we're changing field types. As long as the values that are stored are compatible with the new field type that we're using, the new data type, you're not going to have a problem. If you try to change to an incompatible data type, though, you could lose the data from a particular record. For example, if you had letters in a field that you were changing to a numeric data type, you would end up losing those values. We have set ones that are all compatible. We shouldn't be losing any data. So we want to tell it, yes, we want to continue. Let's go back to datasheet view and see how things look. You can see now that these number columns are right aligned rather than left aligned. That's kind of a good sign that if you've got a number that's right aligned, it is actually a number and not text. Text is going to be left aligned. Looks like we have all of our percentages nicely formatted. Doesn't appear that we've lost any data. So let's go ahead and close out of this table. Next, let's open up the counties table. Double click on it to open up here in datasheet view. You can see we have the county name, and we said before when we're looking at the other county field, that's going to be a good short text. Region is also less than 255 characters, so short text is good for that field. And population, we have whole numbers. They're integers, and because some of these values are more than 32,000, we must use long integer in order to be able to fit everything. Let's go over to design view, and we don't need to do anything with the county and region since those are going to stay as short text. But for the population, we want to change it to a number, and we'll leave that as long integer. Let's save our changes, confirm that we do want to continue. Go back over to datasheet view, and looks like we have all of our records, and these are now right aligned since they're numbers. Let's go ahead and close the table. In the dropouts table, we have the county, which, since it's short text string, we'll use a short text type. School year, which we said that since there's a dash, we need to use short text. And the dropout rate, this is a percentage. So we're going to choose a numeric data type with a double field size for this. Let's go over to design view, and we want to keep county and school year both as short text. For the dropout rate, we'll change it to the number data type. We're going to change the field size to double so that it can store the decimal component. And we're going to format this as a percentage. We'll click save, click yes to confirm that we want to continue with these changes, and we'll view the data in datasheet view. Looks like we're in good shape. So let's close this table. In the schools table, we have a couple different fields. We have county and school name, which we said before. Those are going to be short text based on the data that they're storing. Grades served. This one is also going to be a good candidate for short text since we have just a couple alphanumeric characters. And school type abbreviation, this one should also stay as short text since it has several alphanumeric characters. We'll go over to design view, and you can see everything is already short text. We don't need to make any changes. One thing that we could do if we wanted to would be to change the field size for some of these fields. For example, all of our abbreviations had 3 characters. We could change the field size for it to only allow 3 characters. If you do that, it will not allow you to enter more than the field size that's specified. You may or may not want to do that depending on the values that you anticipate storing in the future. There's not much savings in terms of disk space. The benefit would just be that it helps prevent you from accidentally typing in wrong values. It's up to you if that's a change that you would want to make. There's nothing that we actually need to change within the schools table, so we'll just close it out. Finally, we'll look at the school types table. And here we just have 2 columns, and they both have fairly short text strings, so we'll just keep things as short text. There's nothing that we need to change here. We'll close this table as well. Now that we've changed all of the field types that we believe we need to change, one thing that the instructions hint that we should do is run our queries. Sometimes if you change field types and you do it incorrectly, especially if you change things, for example, from number to text or vice versa, you can break your queries where criteria might not work correctly, relationships might not work correctly, especially for a relationship to work, you need to have the same data type on both ends of the relationship. So if you make a mistake, sometimes you can end up breaking a relationship. Let's just go and run each of these queries to make sure that they still run correctly, because that's going to be a good sign that we didn't cause any problems. Attendance query ran all right. County query looks good. Dropout rate query looks fine. High graduation rates query ran. Schools query is okay. And West Test proficiency query ran without any problems. So it's a kind of a good sign that we didn't cause any issues with changing our data types. For step 4, we're going to identify a field or multiple fields in each table that can uniquely identify each record. These are going to be our primary and composite keys. Let's get started by opening up the analysis questions table in design view. For this table, there should only be one response for each question. With that in mind, the question number will be a good primary key that will uniquely identify each record. On the Table Tools design ribbon, with the question number field selected, let's go ahead and click the primary key button to make that be our primary key. We can save our table, and then we'll close out of it. Let's continue on by opening annual statistics in design view. With this table, we have sort of two different options we can use here. We could have gone and made a composite key where we would have the county name and the school name and the school year all together serve as a composite key, because if we had that combination of all three, that would give us a unique value, because that would take care of the situation where there were multiple schools with the same name, because those schools would be in different counties, and it would also address the situation that there are records for each year for each school. So we could have made a composite key with county, school name, and school year all together. In this case, though, rather than doing that, we have the school statistics ID field that was created specifically to serve as a primary key. As we discussed earlier, if we didn't have existing data, we would have actually made this be an auto number type. Generally speaking, auto number fields are probably going to be primary keys in your table. Even though this one's not an auto number, it's just a regular number. Since we made it specifically to be the primary key, we want it to actually designate it as the primary key. So with school statistics ID selected, we'll click the primary key button. We're going to save our changes and close out of this table. Next, we'll go to the counties table, open it in design view. The county name in the county field is going to be unique because there's only one county with a given name within the state. So we can go and make that be our primary key. And we'll save this table and close it out. Let's take a look at the Dropouts table. Here we have a situation where we're going to need to have a composite key. Since we have multiple counties and multiple school years, and there's going to be a record for each county and school year combination, neither one of those by themselves is going to be able to serve as a primary key. The dropout rate would not be a good primary key because there could also be counties in school years that had identical values. What we want to have here is both the county and school year together serve as a composite key. I'm going to select both of these fields, and then I'll click the primary key button, and you'll see that it puts the key icon beside both of those fields here. That means that they're a composite key together. Let's go ahead and save this change, and we'll close this table. We'll take a look at the schools table next. Now here in this case, obviously we know that there are multiple schools in each county, so the county cannot be a primary key. There are also some cases where there are schools that have the same name in different counties. For example, there are a couple Buffalo elementary schools. In order to ensure that we have a unique key that's going to be able to identify the record, we need to include both the county and the school name as part of a composite key. Let's go ahead and select both of those fields. Then we'll click the primary key button, and we'll save our changes and close this table. And then we'll open up our last table, school types. Here we have the school type abbreviation and the school type name. In theory, either of them could serve as a primary key, but the school type abbreviation, since it's shorter, is going to be a better choice for us to use. Generally, if you have a case where there are multiple fields that could serve as a primary key, going with the shorter one, especially if it's something like abbreviation, that's going to be your best bet. And in this case, too, kind of another reason that we actually are going to want to use the abbreviation as the primary key is that in our other tables, for example, in the schools table, it already has school type abbreviation as a field in that table. So since we want to have, normally for referential integrity purposes, you want to have at least one of the fields in a relationship be a part of a key, school type abbreviation is going to be our best bet here. Let's save our change, and we'll close out of this table. Now that we've set the different data types for our fields and defined the keys for each table, let's build relationships between the tables. To do this, we want to go to the Database Tools ribbon and click the Relationships button. This will open the Relationships window. If you have not opened the Relationships window previously, you'll see the Show Table dialog box. This will allow you to select the fields that you want to display in the Relationships window. In this case, we have already shown the tables that we're interested in the starter database. So we're ready to begin creating our relationships. Relationships are where databases like Access really get their power from. Relationships are what allow us to tie together different pieces of information in different tables in order to be able to construct query results and really make sense of our data. When you're building your relationships, one thing that you'll want to keep in mind is that in most cases, your relationships should basically resemble a connected graph, meaning that either by a direct line from one table to another, or by going indirectly through relationships from other tables, you should be able to get from any one table within your database to any other table within the database. There is one big exception that you need to be aware of, though, with CS 101 assignments. There will never be a relationship involving the analysis questions table that you'll create for your Access assignments. The data with the responses in the analysis questions table is not connected to any of the other data in these databases. So the analysis questions table will never be part of a relationship. When we build our relationships, normally at least one field in the relationship is going to be part of a key. Most commonly, it's going to be the primary key for that table. As we take a look at our database here, a good place to start when building relationships is to start with the tables that have primary keys. We can see that there are primary keys where there's just one field that serves as the key for the school types, counties, and annual statistics tables. Let's go and take a look at the counties table in particular. It has this county field that serves as its primary key. When we're building our relationships, the fields on each end of the relationship need to store the same type of data. So if we're going to create a relationship where the one side is between the county field, and that field from when we looked earlier we know stores the name of the county, the other side is going to have to be to a field that stores county names. We can see that there's also a county field in the schools table, in the dropouts table, and the annual statistics table. When we looked at each of those tables earlier, we saw that it just stored the county name. So those are going to be the fields that we want to create relationships to. Let's go ahead and make our first relationship by going to the counties table, and we'll click on county. And we're going to hold down the mouse button and drag over and then release the mouse on top of the county field in the schools table. That's going to open up this edit relationships window. You can see at the top it's going to have this table, which is the field that we started dragging from. It's the county field in the counties table. And then under the related table, it's going to be the one we dragged to. So it's the county field in the schools table. Down at the bottom, there's three options that deal with referential integrity. And the instructions tell us that for this particular project, we do want to enable referential integrity. What referential integrity means is that you cannot have orphaned records in a database. Where an orphaned record is, there's a record that is supposed to have a counterpart in another table, but that counterpart doesn't exist. An example of an orphaned record would be if we had a school in the schools table and we said that it was in Clinton County. There is no Clinton County in West Virginia. So that would be considered an orphaned record. And orphaned records are really something that you want to avoid with databases. By enforcing referential integrity, you can't create a brand new record that would be an orphan. You can't change a record if it would create orphans. And you also cannot delete a record if it would create orphans. And referential integrity is generally something that you're going to want to use in your databases just to help ensure that there aren't problems with your data. There's two related things here. What Cascade Updates does is if you make a change to a record that would create orphans, it prevents orphans by automatically going and changing the values in the related records. So in this case here, if I change the name of a county, if for some reason, we wanted to rename Wyoming County to Montana County, for example, if once I change the name of the record in the counties table, it would go to the schools table and update the name of the records there as well. Cascade Updates is generally something that's okay to use. You might want to consider it for your database. Cascade Deletes is something that you need to think pretty hard about before you use. What Cascade Deletes does is if you delete the main record in one table, it's going to then go to any of the related records in other tables and delete those as well. So if I deleted the record for Kanawha County in the counties table, it would then go to the schools table and delete the records for all the schools in Kanawha County. That's something you have to be careful about, because if I accidentally delete that record, I didn't intend to in the first place, it's going to result in a lot of deletions throughout my database. If I did not have Cascade Deletes enabled, it wouldn't have let me make that mistake in the first place, because it would have said that there's related schools, I can't delete that county. So Cascade Updates is something that you may want to use. Cascade Deletes, for most cases, is probably something that you don't want to use. Once you have everything set up however you do want to configure it, go ahead and click the Create button. You'll see this line was created, and it connects my two fields to show that they're part of a relationship. Since I use referential integrity, it's also going to show me that I have a one-to-many relationship. That's what those symbols mean, because there's one county, and it can have many schools that are related to it. Let's go on and continue to create relationships involving the counties table. We see here that we have the county field in the counties table and one in dropouts. So let's go and make a relationship there. I'm going to drag over. I don't need to make any changes to the top, but down at the bottom, I'm going to enforce referential integrity as the instructions ask me to do so. I'll click the Create button. And then I'm also going to create a relationship between counties and annual statistics. So I'll drag to make that relationship, and again, I'm going to enforce referential integrity and click Create. Taking a look at our other tables, we see that school types also has a primary key with this school type abbreviation field. This field only appears one other place in the schools table, so let's go ahead and make a relationship to it. So I'm going to select school type abbreviation under school types, drag up to school type abbreviation under schools, release my mouse, and I want to enforce referential integrity, and then I'll click Create. The only other primary key in this database is School Statistics ID in the Annual Statistics table. This field does not appear in any of the other tables, so there's no relationship to be made there. Now that we've gone through all the tables that have primary keys, let's take a look at the ones that have composite keys. And we'll start off here with the schools table. Here we have a composite key that has county and school name. Let's see if these fields appear in any other tables together. And in this case, they do. They appear in annual statistics. We have county and school name. Let's go ahead and make a relationship between those, because it makes sense that we want to have them related. Annual statistics stores the annual statistics for each school. To make this relationship with the composite key, select one of the fields that we're going to have involved in the relationship. I'm going to choose county and drag it over to its counterpart in the other table. So I'm going to select county in annual statistics. I'm going to release my mouse there. Up in the grid here at the top, I need to now add the other fields that are going to be part of this. Since it's a composite key and I'm making a relationship based on both fields, I want to go and choose school name for both sides. I'm going to enforce referential integrity, and I'm going to click Create. One moment though, one thing I just want to point out to you, sometimes you might have problems if you're using referential integrity where it will not create a relationship depending on the order in which you selected the two tables. When there are multiple fields involved in a relationship, Access is picky about the order, whether it's table or related table. Generally speaking, the cases where it's a key field should be under the table side on the left. So in this case here, we're in good shape. We'll go ahead and click Create. There's no other case where we have county and school name together in any others are tables, so we're done making relationships with the schools table. Let's go and take a look at the Dropouts table, and here we have county and school year as our composite key. And if we look, we see that those same two fields appear in the annual statistics table. Let's go ahead and make a relationship based on those. So I'm going to drag from county in Dropouts to county in annual statistics. Release my mouse. And in this case, I need to add the school year field as a second field for both sides of the relationship. Go ahead and click Enforce Referential Integrity, and we'll click Create. And at this point, we've created all the relationships that we're going to need to make for this database. We want to go ahead and click Save and click Close to close out of the relationships window. The final thing that we need to do for this database is to run the compact and repair database utility. This serves to help shrink the file size. Access databases can become bloated as you especially make deletions and additions to your records. Compact and repair helps shrink things down so that the files take up less space. Let's go to the Database Tools ribbon, and we want to click the Compact and Repair Database button. In this case, the utility ran without any problems. Sometimes you might get an error message saying that the file was in use. If that happens, you can just continue on with the rest of the project. You don't need to worry, it's not going to cause an issue with your database. We're now done with this project.